Good morning, students. Myself Amit Yadav. I welcome you all in the mathematics class of Standard 6. And today we are going to do part 2 of chapter Angle. Students, today we are going to do part 2 of chapter 2 Angles. We will see introduction of geometric instruments and also how to construct angle bisector using compass.
Welcome to the lesson on basic constructions. At the end of this lesson, you will be able to Hi, I'm a very important tool in your geometry box. You must be familiar with basic geometrical figures like points, line segments, lines, perpendicular lines, parallel lines, circles, triangles, and so on. To draw these figures, you will need me and some other tools from your geometry box. Here, we'll see the use of these tools. First, I'll introduce you to the tools in your geometry box. Let's begin with ruler. Commonly, it is called a scale. The ruler is a most essential tool in geometry. This tool is used in almost all constructions. Usually, it has a flat surface with 4 straight edges. It has small divisions of centimeters on one long edge. The divisions are marked 0, 1, 2, and so on. Similarly, the other long edge is divided into inches and marked 0, 1, 2, and so on. Generally, in geometry, we measure the lengths in centimeters or meters. So, we'll take the 0 centimeter of the ruler as the reference. The main uses of a ruler are measuring the lengths of line segments and drawing line segments. Next, another important tool in your geometry box is the compass. It is also called as a pair of compasses. It has 2 ends. One end holds a pointer, while the other end holds a pencil. The basic use of this tool is to mark off equal lengths, like a ruler. However, ideally, a compass is not used to measure lengths. The other uses of a compass are to draw arcs and circles. The required length can be set by adjusting its 2 ends. The divider is yet another important tool in your geometry box. It is similar to a compass, but it has a pair of pointer ends. It is used to compare the lengths of line segments. Why do we need a divider to compare the lengths of line segments when we can use the ruler for the same purpose? We can compare the lengths of line segments with the help of a ruler. However, Comparing the lengths with a ruler may not give exact readings. Generally, this type of error is called a positioning error. Thus, to avoid these errors, it is advised to use a divider. These instruments always come with a pair of triangular tools. These are called set squares. As you see here, one of the set squares is an isosceles triangle, while the other one is a scalene triangle. Note that both of them have right angles at one corner. The set square, that is an isosceles triangle, has two angles measuring 45 degrees each. The set square, that is a scalene triangle, has two angles measuring 30 degrees and 60 degrees. The two perpendicular sides of each set square are graduated into centimeters. These tools are used to draw perpendicular lines and parallel lines. Lastly, this is an angle measuring tool, which is called protractor. It is semicircular in shape. The center of the semicircle is called the center point or midpoint of the protractor. This point is always considered as the reference point for a protractor. As you see here, it has a plane edge and a curved edge. The horizontal line is called the straight edge or baseline of the protractor. The curved edge of the protractor is divided into 180 equal parts. Each part is equal to 1 degree. The parts are marked from 0 degree to 180 degrees in both the directions. A protractor is used to measure and draw angles varying from 0 degree to 180 degrees. Here are some important points to remember when you use the tools for construction. Next, we'll see how we can use set squares to draw perpendicular lines and parallel lines. First, we'll draw a perpendicular line to a given line at a point on the line. Here, L is a line and A is a point on it. Let's place a ruler along line L and hold it firmly. Next, place a set square along the line such that one of its edges coincides with the edge of the ruler. Here, you must remember that the right-angled corner of the set square should be in contact with the ruler. Slide the set square till its right-angled corner meets point A. Here, you must ensure that the position of the ruler is not changed and the edge of the set square remains in contact with the edge of the ruler. Draw a line segment along the other edge of the set square. Finally, name the segment as AB. Line segment AB is the required perpendicular to line L. In a similar way, we can draw a perpendicular line to a given line passing through a point not on the line. Here, L is a line and M is a point not on the line. First, let's place a set square along the line L with its right-angled edge in contact with the line. Next, place the ruler along that edge of the set square, which is opposite to the right angle, that is, the hypotenuse. Now, slide the set square along the edge of the ruler till it meets point M. Here, you must ensure that the position of the ruler is not changed. Finally, draw a line segment such that it intersects line L at N. Line segment MN is the perpendicular line to line L. Next, we'll draw a parallel line to a given line through a point not on the line. Here, L is a line and P is a point not on the line. Place a set square along line L such that its right-angled corner is in contact with the line. Place the other set square along the edge opposite to the right angle of the previous set square. Here, we can also use a ruler instead of the other set square. Now, without changing the position of the second set square, slide the first set square along the edge of the other set square till it meets point P. Finally, draw a line along the edge that is touching the point and name it M. Line M is the required parallel line to line L.
This is the angle bisector construction. An angle bisector constructs a line that cuts an angle into two congruent parts. So to start this construction, we need an angle. I'm going to construct an acute angle in the middle of my page. Now the angle bisector is going to go somewhere through the middle here. All the points on the angle bisector are equidistant from each side of the angle. So we know that it's going to go through the vertex, and we need one more point to determine this line. To find this point, we'll start by setting our compass so that it'll intersect both sides of the angle, and then drawing that arc. Now we've created two new intersections, here and here. And from those intersections, we're going to take our pointer, stab in, and draw arcs in the middle of the angle. One here, and one from the other side, so that those arcs intersect. Now this new point is equidistant from both this side and this side of the angle. To complete this construction, we use our straight edge to connect the vertex and this new point. Now we have two congruent angles bisected by this line.